Okay, so another live stream. So today, another second live stream we will have. And I think already on YouTube it started, right? So if you are subscriber, I think you already got the notification and you join. So I just started the second real live stream actually. And today we will discuss a couple other topics. Last time actually I started to discuss network design and architecture, and then suddenly people started to ask questions from many different technologies, and I answered those as well. And then probably I was planning maybe 20 minutes, maybe 30 minutes it would be, but suddenly 1 hour discussion it was. And in fact, there was many other questions, but I had to stop early. Today, I didn't plan actually individual topic. What I want to do is I want to just update what I have done last couple of days, and you should also follow those things, right? I think you are following me on social media already, especially LinkedIn and Twitter. I'm talking about. Thank you very much, by the way, asking my daughter. Some of the audience will be probably my students or my friends. So at the moment we are under quarantine because my daughter got the coronavirus, and she's totally fine. Oh, it has been now 5 days, almost 5 days, and everything's fine. We are fine as well. We don't get the virus yet. We don't have it, but let's see. Since almost 14 days, we have to stay at home. I thought these sessions will be useful for you guys, okay? As I told you, we can talk about many technologies, but let me start first telling you yesterday or day before, I think we recorded a session on OSPF extendability, right? Jeff Tanstra and I, we discussed about OSPF extendability. Probably you heard this term. OSPF is not extendable as ISAS. Hello, guys. And why? ISAS is TLV based, OSPF is fixed header, and we don't have much space. We don't have structure to grow, and so on and so forth. As you know, we are carrying the information within LSA in OSPF, and in ISAS we are having TLVs, and the TLV structure makes the protocols extendable. We have many protocols actually, TLV-based protocols. So ISAS is famously known as the TLV-based protocol, but DNS, BGP, EIGRP, GLBP, LDP, those are also TLV-based encoding and extendable protocols we are considering. And we discussed several RFCs, in fact, in that OSPF extendability discussion. You can watch that video also on the YouTube channel. It's there. So those RFCs such as 7684, 8665, and recently published one, actually Jeff Tanstra also was the one of the author of that RFC, 8920. So why we had those? When you watch the video, anyway, you will get the points. So let me not talk about that video already we have on the channel, so you can watch later on. But the idea, okay, many RFCs we have, not only 76, 84, 68, 86, 65, but we had many RFCs for extending OSPF for specific applications. Most of the RFCs, earlier RFCs, for the resource reservation protocol, RSVP, but there was many other RFCs also for segment routing, for example. Then this RFC actually combining those 8920, combining those stuff Thank you very much. But can I block some users or can I ban? I don't know. Yeah, I did. So hopefully he doesn't want to learn some stuff. And YouTube, these live streams, I think, is not good because of this. So some people are coming and saying, last time someone was saying also using very bad words, and they don't want to just ask the technical questions, it seems, but there was many also technical questions there. Anyway, overall, in this session, you can ask the technical questions as well. But what I wanted to tell you, that OSPF extendability is one of those unique topics actually we discussed, because many people are, you will hear this again and again, TLB-based encoding, and you can just introduce the structure, new structure, and extend the protocol in that way. So we discussed also this, why we had the OSPF version 3 for IPv6, why we didn't use basically OSPF version 2 and just writing new sub-TLVs and TLVs for the OPF LSAs and extend OSPF. So obviously, you will hear also that discussion there in the video. Okay, so today I was planning to talk with the just students actually on the multicast, some students on the multicast, specific stuff on the multicast. Probably we will also do that. But I wanted to just open this live stream and check what's happening, and then update some information that I shared on the social media as well. For the multicast, guys, in this channel, YouTube channel, there are a couple videos, very important. One of them is BIR, bit indexed explicit replication. So the bit indexed explicit replication founded by Greg Shepard and Tony P. I have a video with the Tony P. We discussed about BIR. I think more than 1 hour video you will see there. So many stuff we talked, but in general, what you will see in that video. We have, of course, multicast in IP network, MPLS network, and many techniques for that, right? So we need to understand PIM. We need to understand in MPLS multicast a lot of things. MDTs needs to be understood. Rosen-GRE needs to be understood. And after that, point-to-multipoint LSPs, multipoint-to-multipoint LSPs. So many stuff, BGP and EVPN will come into the picture, and so much different NLRIs you need to understand. So almost Cisco terminology, 27 different profile we are talking about. So you need to know so many things actually from the MPLS point of view in IP and MPLS network. But almost everything for the very large scale networks, you will see the limitations. Okay, so control and data plane state-wise, you will have limitations. And any protocol you will have anyway. But some protocols are more scalable than others. This is one of the design quality attributes, we call it in network design. So yes, BIR is trying to address scalability challenges with the other protocols. Such as PIM or MLDP, point-to-multipoint, or multipoint-to-multipoint, or point-to-multipoint LSP with the RSVPT. Those scalability limitation of the protocols are addressed with the BIR. There are some challenges, of course, for BIR as well. There is no free lunch. So especially from the software, hardware upgrade point of view, there are some expectations when it comes to that technology. Have a look at that video from the YouTube channel as well for the multicast. Sure, you need to have some background knowledge on the IP multicast and maybe MPLS multicast as well to understand the advantages of bit index explicit replication, guys. So that is for the multicast update. So also ISAS, some students were asking, can we talk about ISAS, etc. Sure, we will discuss as a training purpose. At the moment for that one, I need to share the screen and then start from scratch. Probably just from design point of view, high-level ISAS will take around 3 hours. And I think YouTube live stream is not suitable for that. We will do that for the students, but here we can get some comments if the attendees have any questions. I mean, I can answer them, and then I can read the comments and then help basically, guys, your questions. What else? For the ISAs also, we have some videos in this YouTube channel also. You can have a look. Not only ISAs, but many routing protocols. In fact, most of the videos in this YouTube channel also related with routing. From routing, especially the routings that protocols or thoughts, insights that you cannot find from many other places or almost anywhere. The reason I discussed those protocols with the founder of those protocols, and we discussed the architecture there. So what they had in their mind when they introduced those protocols. Of course, with the founder, you don't discuss on individual vendor how you can configure and how you can tune some parameters, etc. So why you invented that? What was the real reason for the business benefit, for example? What was the case? Why already we had alternatives? Why we have this one as well? Like beer, think about it. Or Rift, for example. On the YouTube channel, you will find Rift videos. Inventor of Rift is Tony P also. Rift is routing in FAT3. FAT3 means closed topology. Close means leaf and spine, you know that. And specifically, it's used in the large-scale data center. But by the way, let me remove this one. It seems that I will talk a little bit long, so let's focus. So closed topologies, leaf and spine. So leaves are not connected to each other, spines are not connected to each other. In many cases, there are some special cases that you connect as well. Okay, in those topologies, especially in massively scaled data centers, we are looking for special routing protocols because there are requirements for that. Though some people still argue we are managing our network with the OSPF, very large scale network. I think Amazon guy was doing that. Of course, you can introduce always more complexity and you can manage the things in a certain way. So in their case, I think multi-array OSPF design, hierarchical OSPF design they were doing anyway. RFC 7938 is not saying so different things, but at the same time, BGP is giving you, RFC 7938 is using eBGP in the massively scaled data centers. In that RFC, of course, there are reasons that you are using BGP, policy reason, traffic engineering, manipulation reason, a scalability reason, of course, so on and so forth. And then explaining what should be the ASN allocation schema for pet hunting, for convergence, etc. So lots of stuff. By the way, I covered those RFC 7098 eBGP using external BGP. eBGP is external BGP. iBGP is internal BGP. So some large-scale networks in their data center, I know they are using also iBGP. So you don't always have to follow the RFC. By the way, RFCs probably, if you are following my YouTube channel, you know that there are many different type of RFCs. I mean, 7938 also informational RFC. So vendors, they don't have to implement this exactly the same way what RFC is suggesting, right? People probably don't know this distinction when they hear, for example, these days, SDA, Software Defined Access Cisco, LISP technology is the control plane of this SDA, RFC 6830, I think. It's also experimental RFC, though it's commonly used now, and commonly used experimental RFC can become standard RFC, by the way, in IETF. Okay. Anyway, I was talking about the routing protocol in the YouTube channel. So Rift, I was telling you. Rift is addressing also some certain challenges, scalability point of view. BGP was already there. Traffic engineering support is coming with that one as well. But topology information is missing, for example, in BGP, right? Though topology information is missing, and there is a new IETF working group called LSVR, Link State Vector Routing Working Group. And in that, I think chair is Keyur Patel. And they are working on the solution called BGP plus SPF. So Why you are combining BGP with SPF? Because you are getting the advantages of BGP, such as traffic engineering, packet manipulation purpose, like mice and elephant flow separation on the DC fabric, and scalability, obviously. But you are replacing pet selection with the SPF in that case, so it's helping for the control plane convergence of the BGP. Otherwise, you will hear almost always BGP is slow. This is wrong. BGP is not slow. Okay, this is not enough explanation. So that's why people, I am recommending people, when you read from some places, definitely you should know who is the author, who wrote that document, and when it was written. It's important. Okay, BGP is not slow. BGP control plane convergence might be slow. Depends on many factors actually. Minimum route advertisement interval, number of prefixes, is there a full mesh IBGP or route reflection as an hierarchy? So many things for convergence, also control plane convergence. But if you are relying on the data plane convergence like BGP peak, you might of course converge much faster. Now some careful advanced guys might think, okay, Orhan, but we don't use BGP peak, BGP phase 3 route in those massively scaled data centers, large scale data centers. Yes, we don't, because it would be, we are having ECMPs, symmetric topologies, symmetric and densely meshed topologies, we call them data center route, those massively scaled data centers, their physical topologies, okay? Densely meshed and symmetric. What does symmetric mean? So same capacity. You don't have 40 gig over here, 10 gig over here. So you have 40-40 or 10-10. So you have ECMP capability. When you have ECMP, it's about hashing anymore on the local device based on some values. Basically, most of the time we have those 5 tuples: source destination IP, source destination port, and protocol ID. But you can have different places. You can have different entropies. Am I going so fast, or is it a little bit confusing what I'm talking about, or are you able to follow, guys? Because some of these things really require some background knowledge, to be honest. Okay, some people might be enjoying, especially if you know these topics, routing very well. You might be enjoying, and you might ask questions also while I'm speaking, because I will continue like this. I don't know. Whenever it's boring for me, I will end up there. How many minutes, by the way? Past almost 17 minutes, right? If you type in English would be better, so I can understand you what you are writing now. By the way, I am from Turkey originally, so he's writing in Turkish. I can understand, but you cannot. That's why let me not translate every time. Try to type in English, guys. If you cannot type, you cannot understand also what I'm talking now and why you are spending your time now. Your time is valuable for you. Okay, we were talking about data center routing, right? Symmetric topologies I was telling you. So we don't call, in that case, when there is a failure, we don't have phase 3 route. Data plane convergence is phase 3 route, we call it, okay? If you are making the convergence faster in the control plane, we call it phase convergence. At least I call it phase convergence. And for me, the difference between phase convergence and phase 3 route, one of them is control plane convergence, another data plane convergence. I teach also students in this way. So phase 3 route is phase convergence, but phase convergence is not phase 3 route, I am telling them. Same thing that what I tell them, network architecture is network design, but network design is not network architecture. Not every design is architecture. Because the decisions architects might give you, might let you do sometimes those not very important decisions they can let you do, okay? That's the same idea. Phase 3 route obviously gives you phase convergence, but phase convergence is not phase 3 route because you are not calculating the path before the failure, and you cannot install those paths in the RIP and FIP before the failure, okay, in the phase convergence case. You do it in the phase 3 route case. In the data centers, we have symmetric topologies. That's why we have ECMPs. That's why you don't need to do data plane phase 3 route techniques. You don't have active standby control data plane. You have active control and data plane in the ECMP case, or weighted ECMP case, WECMP, or UCMP case. Weighted ECMP, some people maybe didn't hear. Before Cisco, I think they have a feature on especially BGP routing, DMZ bandwidth, they call it, okay, weighted ECMP. So based on the capacity, you can take into an account, and 8 gigabit to, or 10 gigabit, let's say, and 1 gigabit link, and 10 flow over here, 1 flow over here. Of course, flow bandwidth might be different though. Any question? I don't know. For the certification, let's not talk today about those. If you have individual question for the technology, go ahead with the technology question. Any type of technology can be, that's okay. Just let's not discuss the product as well. Does ASR 9K support the VPLS PBB? I don't know, maybe it supports or not. But let's talk about VPLS provider backbone bridging. I don't know, whatever technology is. Okay, and then let's discuss the architectural stuff with them. So if I do versus if I do other stuff, what would I lose? What would I gain? In which case I should choose one. Which one? Not again the configuration. How you will configure VPLS, BGP VPLS on Juniper box. So you can configure it. You can find the information on Google. What I told you, what I told on the LinkedIn, I think I shared, the architecture, the stuff you cannot Google. That's why while we are live, I'm always saying, come and ask the questions that you cannot find on Google. Let's discuss those. If I know the answer, will be very useful for you. Okay. Hello, Mohammed. So I was telling you about this data center routing stuff, Rift. Definitely, with the videos on the YouTube channel from Rift, not only Rift, but I didn't tell you, BGP plus SPF video also I have on the YouTube channel. Maybe you missed that. Maybe you are new to this channel. That's totally fine. I am just introducing what you can find. And in fact, I am reading each and every comments also under video. So when you ask technical questions, I'm trying to answer those as well. So that's why watch the videos. Some videos I know very long. Some videos you may not understand what I am trying to say. If you just mention which exactly minute and second your question is, I can watch there, and maybe because of my pronunciation, or maybe you didn't hear that term before, that's totally fine. I can just answer your question, okay? That's very normal. A couple days ago, somewhere I used the term fast rehash, and the guy told me I never heard that. And in fact, for fast rehash, for that operation, he was using fast reroute. I just told him we call it fast rehash, and actually it turned out that V is couple guys only. I mean, it's not yet, it seems industry standard, but though the guy, Jeff Tanstra and me, we are using that term very frequently to, actually, it's a hashing and rehashing, fast rehashing, it's called. If I didn't see the IETF term because for that, but Jeff got the patent for that. That's why I'm using it as well. Like we are, because we are very good friend, I think that's he's allowing me to use. But again, sometimes that's okay. Sometimes you maybe throw some words and people start using that. If there is no definition, that's fine as well. And I think we have so many definitions like that. How I find this amount of talk, right? I never planned anything for today. Okay, this kind of wordings that we throw a lot. Like when I talk about complexity, I say complexity is important and necessary thing, right? So we need to talk maybe one day very long just about the complexity, network complexity, and why it is important, understanding complexity, if we can, complex versus complicated, all those kind of stuff, fundamental stuff we need to probably talk one day. But anyway, I have also on orhanergun.net, my website, post on network complexity I wrote maybe 5-6 years ago, and mentioned there one word, unnecessary complexity. Of course, I didn't know because what to say for the complexity which we don't want, for the complexity which is not necessary, unnecessary complexity, I just said. But when I research more and more, I am seeing other fields. Of course, they are dealing with their own complexity. System engineers, their own complexity stuff. Database people, software guys, they are all, or even for others, not only technical people, but biologists, for example, they are also dealing with the complexities. I actually watched some videos on the birds, and when they fly, some people are dealing with how they are not basically crashing each other. So they are trying to solve those kind of things. So when it comes to complexity, as I told you, unnecessary complexity, I was saying that, but I learned other terms when I started researching about that topic. Accidental complexity, for example, essential complexity, accidental complexity. There are many other terms. Of course, we can use those terms in our field as well to explain, to express something. Anyway, okay. First question, I think. Let me see. No, couple questions. Oh, sorry, many questions. When did you ask these questions, guys? While I was talking, there are a few questions. Now let's go through them. Which is better? Okay, Flex VPN or Easy VPN? There is no better in the first place. This is even the title, Network Design and Architecture. Let me explain in this way. I will not go through the Flex VPN, which is DN VPN phase 4, but Cisco thinks that way anyway. But there is no better for us. There is no good. There is no bad. There is no better. There is no worse. There is no best. There are only situations, in which case, actually, even just one situation, we cannot tell which one is better. Okay, we need to understand there are functional requirements, there are non-functional requirements. I don't call them non-functional requirements, quality attributes. There are constraints, which is already made decisions we need to know, and limitations of also that network. Then cost and risks come into the picture as well. And based on many of those stuff, prioritizing them by talking with the stakeholders of that stakeholders of that company, of that network, then we can talk something. Okay, so there is no better. Orhan, RIP versus BGP. Which one is better? There is no better. Orhan, VPLS versus EVPN. Which one is better? There is no better. Okay, just we need to talk about in which case we are talking about. Okay, we need to set the context from this point of view. Okay, this might be considered better, might be again, because things might change in a couple years. Guys, okay, there is no better for us. Don't ask the question in that way. It's better you learn what is architecture, what is design. Okay, please have a look at my previous video for that one as well. Who asked that? That better? Marlon. Please have a look at this network design and architecture discussion 1. Okay, not the previous one, the one before. Welcome. So when you look at that one, then probably next time you will ask me from the convergence point of view, or which one? From the security point of view, which one? Okay, I cannot say otherwise. OSPF versus ISAS, which one is better? I like more ISAS. So at the end, it might come and to the conclusion, whichever you like might be the better. And I like ISAS, you may like OSPF. But business owner may like OSPF or ISAS, depends on their number of network engineers, which protocol they are familiar with. Otherwise, there is a budget concern. They need to go through the learning curve. Learning curve is requiring most of the time budget and time. During that time, when there is a problem, who will troubleshoot that network? So there is no better. Let's hopefully by the time we will get this point. Can you please explain EVPN and LISP? This one is, for example, probably right question to ask. Can you explain not the which one is better, which one is best in layer 2 VPNs, etc. EVPN and LISP. EVPN, I have 5 days, 25 hours course. Can you please explain when you say also, again, comes down to from which aspect I should explain. And LISP also, we have another 5 days planned course. I mean, why I'm saying this, they are so long topic. But let me try for you in a couple minutes at least. Actually, very valid question, Mohammed. By the way, if I answer this question based on timing, I don't have limit for today, by the way. Based on timing, if I go talk too much about this, if I cannot find so much time for the other questions, sorry for that, by the way, I should say that. Okay. EVPN, as you might know, came for layer 2 VPNs in the first place, okay? Like a next generation VPLS in the first place. Though by the time it's evolved, and it started to support, of course, layer 3, like classical 2547 type of VPNs as well, or 4364. So it started to support layer 3 VPNs as well. It started first RFCs also we are seeing for the MPLS data plane, and even PBB we've seen. But later on, and more commonly, we started to see which data plane with the EVPN, VXLAN. So today when we came to, there is no conclusion, I should say, because there is still ongoing enhancement on EVPN, and we have 11 different route types with that. 11 reminds probably to you OSPF, right? 11 different type of LSA. So those different route types should be understood very well, because they are the basis of how this protocol works. OSPF, can you talk about OSPF without understanding the LSA types? Why we are using router type 1 LSA, for example, right? Every router generate that, what they put inside it. So OSPF version 2, version 3, totally different, right? Because OSPF version 2, that type 1 LSA for the reachability as well as topology. So if you create even loopback interface, it will trigger the full SPF calculation in an area. So many things to know. EVPN, same thing. Type 1, okay, when we say type 1 LSA is used for many purpose, so for auto discovery we say, but for the ESI, so you are telling everywhere that this basically MAC address here, this is the ESI, sorry, MAC address for the type 2 I will talk about. This is the ESI, and these are the VTAPs for this ESI, and everybody knows this now. This is only one type, and it's used for aliasing. It's used also in combination with the type 4, used for the DF election, designated forwarder election. Only even this concept, designated forwarder, should be understood very well, because we are using that in many different places in networking. Not only EVPN, we are seeing that one in the IGMP, we are seeing in the PIN-BIDER, we are seeing in OSPF and SSA, right? DF election. So there are many places, and different places might be a little bit working differently. But this is very domain knowledge, so probably designers should know, but architect guys shouldn't deal with all these details, huh? Different versions of DF election, where it is used, etc. But of course, I am coming from the design background at the end. So type 2, you are advertising MAC IP as well, which means you have an ability to reduce the, tell me, by doing the ARP suppression, those ARP messages. A good thing, of course, from many aspects, because ARP, as you know, BAM traffic, broadcast traffic, so one of those BAM methods, broadcast, unknown, unicast, multicast, you need to float everywhere, and everybody needs to process, even the hosts. Reducing it is a good thing. And you need to know this, not only EVPN. What are the other layer 2 mechanisms, other layer 2 technologies which can do this ARP reduction? The OTV can do that as well. VPLS, they don't do that. VPLS is data plane learning. Control plane learning allows you to do this ARP suppression. OTV is control plane learning as well, ISAS underlay. So we need to first understand maybe the basics, like what is control plane, what is data plane in the first place. So EVPN is huge, and probably one of the complex, not understanding-wise. We can explain you in 10 hours, 20 hours, even without, design-wise, of course. If configuration involves, maybe 50 hours I need. But we can explain the very detailed stuff about the design and architecture of EVPN in 20 hours. In fact, we are doing the course for that, Tony Passan and myself. You can find one video with Tony and me. Tony wrote a book on the EVPN, by the way. Tell me, 1 hour and 46 minutes video in this YouTube channel. Orhan Ergun YouTube channel. Of course, you guys hopefully are subscriber. If not, please do the subscription, because this kind of live video just 2 days ago when I did, or 3 days ago, I told you I will do it again and again anymore. I like this. Okay, because get the questions from some people who are not my students, but totally foreign people, and answering the questions. Ask me anything sessions, AMA sessions. Nice. What I was saying, lots of different route types we have. 5 of them is fundamentals, similar to OSPF, those 5 fundamentals LSA, though you have 11 different LSAs there, 11 different type of EVPN routes here we have. 5 of them is essential from type 1 through type 5, and we discussed those high level in 1 hour 46 minutes video in this YouTube channel. Have a look at that one as well, Mohammed. So EVPN is, if I summarize without going through those route types again, otherwise I cannot find the time to answer other people's question. Control plane started as a layer 2 technology. Then today, even those classical layer 3 VPNs come with the 2547 can be supported with the L3 VPN, with the EVPN as well, Ethernet VPNs as well. So is it better to say still Ethernet VPN? Another question, which brings me to other discussions, like there are so many wrong wordings probably in networking, or misleading wording in networking by the time we are discussing them. Last time I think I gave an example in the live video, IPv6 transition mechanisms. So like that, so many. But Ethernet VPN now evolved. That's why I'm telling you, when you research something, when you read something in networking, things are evolving. So what you learned 3 years ago may not be true today. If article which you read today is 7, 8 years old, please check it again from other resources as well. Even if I wrote that, I'm telling you, of course, I'm not special. 7 years ago, whatever I knew might be wrong today. And I don't have time to be honest, and many people don't have that time to update their each and every article, books, etc. And you don't have even luxury. So I sold you hard copy book 7 years ago, and now let's say EVPN was not there 7 years ago, but like 5 years ago, then EVPN was there and layer 3 VPN was not introduced. You see my point. Now it is. People even started to use it, but in the book it's not there. So you cannot say this is wrong. Just time is important. Okay. Kindly share the video link about which one? About what? So because I will come there later. LISP. Let me talk a little bit about LISP, and let me give you update about LISP as well. Then next question I will go through. LISP on the other side came from different perspectives. So EVPN started with the layer 2 data plane and supported layer 3. LISP is IP in IP encapsulation. Okay, so it is for layer 3 VPN. Can you create? Of course, you are creating VPN as well with the LISP, but for the layer 3 IP in IP encap. When I say IP in IP encap, V4 in V4, V4 in V6, V6 in V6, V6 in V4. Oh, when V6 involved, you can ask your question now. As a tunneling mechanism, as IPv6 transition method, can I use LISP? Of course you can. But I talked about this one as well somewhere, probably Orhan Ergun LISP, IPv6 transition, you can find it. Anyway, let me talk about more on the LISP side. So RFC 6830, we have experimental RFC for that, and the other founder of LISP is Dino Farinacci, our good friend Dino, and you will see 2-3 videos about LISP and other stuff, but mainly LISP on this YouTube channel, Orhan Ergun YouTube channel with Orhan Ergun, Dino Farinacci, and I think also Jeff Tansura joined us. Jeff is the co-host on my many videos actually with me, maybe 10-15 videos in this YouTube channel with him, over 20 hours maybe. And he probably also published maybe 100 RFC, if I would say, I wouldn't exaggerate. Jeff Tansura, and for Dino also, many RFC you've seen today, like MPLS RFCs as well, belong to him. LISP also, his job, his work, and lispers.net, for example, on his website, lispers.net, he's doing the consultancy now. He was a Cisco fellow, but working now on his company. You might want to check lispers.net as well. Good idea. It came as an IP in IP encap. It never, and it cannot be replacing the BGP on the global internet. Maybe some of you heard that somewhere, because I've seen again and again, even this year. Why you come to that conclusion, I don't know, but LISP, in the very first place, founder invented LISP to replace the BGP protocol. Never, cannot be, because we need that underlay. And in fact, we discussed that one also in one of these YouTube videos, and I discussed that. Okay, specifically I asked him, did you think about this? I mean, you cannot, but what was this intention anyway? Of course not. So underlay is necessary anyway. What else? So about the LISP, what we can say, didn't evolve, but can carry layer 2 as well. Got my point? So it can carry layer 2 as well, but so much enhancements on the EVPN side. We have standard RFCs on the EVPN. Then you can ask question, why Orhan Cisco used LISP as a control plane in the SDA, software defined access, their campus automations, campus LAN solution SA. That's also another discussion we also did on the YouTube channel, so let me redirect you to there. You don't need a link for this. All these videos on my YouTube channel, just if you type LISP, there is a search area, I think, when you click on the videos tab, just search my name and LISP. You don't need to even put my name, I think, because my YouTube channel. So LISP, EVPN, whatever, then you will find the videos, maybe more than one. Watch all of them. Of course, while you watch, like them as well. Okay? And refer to your friends too. Another question. So much time we spent on that, and almost now 41 minutes. Let me see. Marlon, he will respond, there is no better, only different. Yeah, he's my student, so he knows what I will say. There is no better. There is no better or best. If there is best, why we have others? There is no worst also. From some aspect, that the worst technology you think, I can make it best technology in some situation, okay? It's all about context. I'm telling to my students also, I know everything. Because I talk technology, I talk design-wise, design and architecture, so I cannot be correct, I cannot be wrong. So in all this situation, if from this aspect, if these are the pre-decisions and this satisfies all these requirements, then this is the best, then I will be correct. Because I narrow down the problem space here, and only solution is this. I am saying to them, I'm correct. At least in this time, as of 2020, November? Okay, I am correct. If I don't know the technology that we are discussing, then I don't do anything. I don't say anything about it. Sure, I may not know those technology, but the technology, if I know, I cannot be wrong, I am saying. That's my point. But you can say, if you talk very high level, then you can be wrong. Of course, that's why I didn't tell this guy which one is better. Because he should ask the question, or I should start answering from this aspect, from the another aspect, from the another aspect, etc. When those combined requirements come together, this is the best. I mean, for this one also, we don't have time for that a lot. Let me go through another question. Gary, in enterprise networks, many organizations have collapsed core, layer 3 switch for the core. It is easy to add routing functions to the core switch. What factors influence when to get a separate router? Scalability and also modularity. So when you want to remove, for example, why you want to have this collapse distribution and core collapse, so on the same box, or different boxes. One of them, of course, scalability. Do I need to draw the topology, like if you have multiple places, multiple access collapse distribution core, and then try to connect them together in a full mesh topology? I mean, all of them has to be connected. How you can connect? Either you will introduce hierarchy, so hub and spoke you will do, or you need to connect via full mesh if everybody will reach to each other. Or there are other ways as well. Of course, you can say ring as well, then I need to give you more requirements. So one of them, at the end, if we talk more and more, if I draw, we will see that scalability. Okay? Number of bugs usually will reduce with that. If there are multiple places which will talk with each other, there is an example for this. I think I can talk a couple more minutes about this one, Gary, so you can get the answer. So if campus network, we come from there, maybe I need to draw for many people, but now there was, and real time also, in real life, what happened? I was in one service provider, and those guys, they had kind of classical MPLS network, okay, CE, PE, and P devices, right? You hear that way, at least in the theory. Those guys, they remove their P function, P routers from the network, core network. I mean, P device, by the way, backbone device, core we say. By the way, this service provider topology is not different from your campus network. Campus, if you say access distribution core, here we just say access aggregation and core. So, or you can name it what? PE, P, and another PE. Okay. And what else? Those guys remove those P devices, which means they now put that function on the PE devices. What they need to do in this case? If you remove one layer from the network and still you want to have the communication between those endpoints, you need to add extra link, extra circuit. So you remove the device, you need to put extra circuit, guys. Okay? So for overall end-to-end communication between each and every point. And trade-off, so we need to always look for the trade-off. In their case, circuit versus having those routers. Of course, having routers, you may think, okay, it was staying there. Why they removed that and started to add new circuit? First, you need to know their architecture. In their case, they had the circuit. So they own the circuit. They are the incumbent service provider in that country. Anyway, another case also, it's not free to keep those routers in your network. You need to pay the license, you need to pay the power cost, you need to pay the environment cost, and so on and so forth. So it's all about cost trade-off at the end, and for them, keeping those P-layer core routers very expensive. Okay, so they could put there and reduce the number of link, but they decided to otherwise. In classical campus network, though, you put those extra core layer when you want to reduce the number of connection between the devices. So turn the topology from the full mesh between the core devices to the hub and spoke. Hub and spoke brings the hierarchy to any solution. So hierarchy brings the scalability. Okay? Classical example is route reflection. If you have IBGP network, you need to have full mesh IBGP. The reason, because by the way, full mesh IBGP is split horizon. When you have split horizon in technology, as a technology split horizon, it pushes you to have on the overlay full mesh. Classical example for this, again, not only IBGP, but also VPLS. A VPLS you have also split horizon, which pushes you to have at the overlay full mesh pseudo wire. Anyway, let's not go there now. When I try to explain something, I need to talk many other things, and then you need to connect the dots, and it takes time. Gary, did you get the answer, or should I continue a little bit more? So it will take more and more time always to talk. By the way, if you guys have still question, go ahead, ask. And meanwhile, let me go through other questions. So your answer, Gary, is scalability and modularity. So why modularity? I mean, if you remove that distribution and collapse distribution core device from the network for maintenance reason, let's say, and you will affect a lot of things now. Instead, actually, in many cases, you will. Even if you separate those functions, still you may have second distribution switch, but in this case, distribution and core, if you collapse, if you remove that, you have still maybe second distribution collapse, another device. So usually this modularity comes to scale up versus scale out discussion, actually, the trade-off, I mean. Okay, but on the other side, scalability is one thing that immediately comes to my mind for you to look as a trade-off. Okay, another question. Can we say LISP essentially is going to help optimize BGP routing table? You can, and not only BGP routing table. It is there, LISP, in the first place also, it was invented to simplify the underlay routing protocol, whatever it is. If you are using LISP between the internet gateway endpoints, IGW routers, basically it will simplify the underlay for. But if you are using Lisp in your network, internal network, it will simplify the underlay IGP in this case. So OSPF, instead of now you push those local subnet into OSPF control plane, you remove those local subnet, and we call them in the Lisp terminology EID space, endpoint identifier, and we put those subnets to MRMS, so the database. And then authoritative server logic, we need to ask whenever we need that reachability, we are asking from MRMS, can I know where is this destination, etc. Classical operation, but you are simplifying underlay routing, of course. Correct. What else? Advanced design. Another Turkish, Ferdi. Please don't ask in Turkish. You are asking Turkish subtitle. I don't think it will come. I don't have time even to put English subtitle. So better you come to us. And I mean, start studying English definitely for the Turkish people. I can say that. Okay. What else? Why we need LSA type 4 when we already have LSA type 3 as summary in OSPF? Actually, a couple days ago, I was discussing this in one of the OSPF class. I was discussing that. That is interesting story, because normally, guys, we need to little bit very fast. I need to go. We need to little bit understand what are those LSAs. LSA type 4 in OSPF version 2, what we are using for when we have multi-area design, hierarchical area design. When there is a redistribution in, let's say, area 0, backbone area, those redistributed prefixes will come as type 5, and the scope of type 5 LSA is domain-wide. So it will go to the non-backbone area as well, and in the non-backbone area, external LSA will be known, but who is advertising that will not be known. Because in the backbone area, ASBR, that advertising guy, redistributed guys, will be known by type 1 LSA, router LSA, right? They will know from the type 1 LSA. But type 1 and type 2 LSAs cannot be exchanged between the areas. They will be summarized, but summary route is known very wrongly, actually. For example, in summary route, you don't send topology information. You send only reachability information, so prefixes. Anyway, so cool. What happens when we have type 5? ABR, it sees that ASBR type 1 LSA, since it cannot type 1 to another area, it is regenerating type 4 LSA and sends for that ASBR, that type 4 LSA. Probably for decoupling purpose, we are having that separate type 4 LSA, though how you would mention this is just for this ASBR purpose, ASBR reachability. So probably we don't have separate space for that, right? That's why, so just to mention about, okay, the coupling, I mean, for this type 5, this is the corresponding router, the guy who is advertising this router, we are sending this. Otherwise, there is no extra metadata information that we can send. Could you do this with opaque LSAs? Probably yes, but type 3 is not the place for this. There is no extra field to mention, okay, this is this information we are sending, and you should combine for the external LSA, whoever is advertising it. Got the point. But for the type 10, for example, we are doing this for the segment routing. When we use segment routing for the intra-area. What else? How would you define MPLS? Okay, I think, Adil, since you are asking, you are not asking now, very high level, okay, is MPLS, can you compare it with the LDP, RSVP, etc.? Okay, how would you define MPLS? Is it switching or routing protocol? Or is it in between? It is switching, obviously. By the way, the name is saying that, but it is obviously switching as well. Why? Because you don't do any destination-based lookup. IP routing works based on the destination-based lookup, and IP unicast routing, I should say. IP multicast routing works opposite, towards the source. So far, so good, right? MPLS, though, those labels are not destination-based lookup. So what you do, you have the mapping table, right? 20 comes, 30 goes. 10 comes, 20 goes. Okay, in, out. So you have that binding mapping table. When you see switch mean, okay, if I see this one, immediately switch, so change it and send from this interface. That's why from the CPU consumption, resource consumption point of view, MPLS is more efficient than IP routing lookup, and it was the very first reason MPLS was invented. So if someone asks you, and in fact, in one of my MPLS quiz, I think I'm asking the same thing, what was the reason of, in the first place, the history of the MPLS? It was the reason. Though I watched those, I think Russ did the session with for the history of maybe LDP as well, and I remember history of pseudo-wire. There are a couple knowledge there, mystery knowledge. So the inventor of that is actually for the pseudo-wire is Luca Martini was there. We have LDP pseudo-wire, we have BGP pseudo-wire, as you might know, Martini Compella methods, etc. We are saying, okay, Adil, since you asked the MPLS, I need to talk a little bit about those as well. Let me talk a little bit. So first reason, let me not go to that level now. First reason of the MPLS also was processing, faster processing, because it is switching operation, not the destination IP-based lookup operation. Okay, very fast. Another question. By the way, we are coming to end of the question. If you don't ask more question, I will finish it. If you ask question, I will continue. Think about it. Otherwise, when I answer the last one as well, we will finish today's session. To make MPLS, you are saying, I think, okay, MPLS data plane to forward the data, you need to have loopback /32 between PEs and PE. Would you please explain the reason why we need /32 loopback? This is classical old LDP RFC operation he's asking. Let me explain a little bit about that one. And as I said, while you don't have any other question, I will finish the session. Otherwise, I will explain. Ask questions that you cannot find on anywhere. That's beneficial for you. So earlier version of the LDP, first version of the LDP RFC, looks for the exact match for LDP and the IP routing. So which means if you have /32 for the loopbacks, we create /32 IP address for IPv4, obviously, 128 for the IPv6. So /32 for LDP to assign a label, you cannot summarize, because in the FIB as well, forwarding information base, you need to have /32 IP prefix for LDP to assign a label. Though after that, there are many approach emerged to assign a label, to bind a label for the summarized prefixes. For example, RFC 5283, not this down. RFC 5283, famously known as extension for the LDP. So you can, instead of doing the exact match, so we are looking for even summary or even default route. So you can now, LDP, I mean, assign a label to the prefixes, summarized prefixes. Okay? There are many methods, I said, is famously known. Another one is RFC 3107, which means carrying those loopbacks not via IGP, but in BGP. And now we have also updated RFC 8277. 3107 is very old, and there are some mechanisms that we were looking from the 3107 but was not supported. 8277 is supporting. I will not go there now. In sometimes in sessions I am discussing also. What else? So you have many methods to carry. By the way, this 3107 carrying those loopbacks via BGP, not via IGP, as I told you. You need to advertise the prefixes via BGP. And if you need still MPLS, obviously you have to have 3107. Why? Because if prefixes are learned via BGP, only MPLS can assign a label for the BGP learned prefixes. Okay? But if prefixes learned via IGP, 3 protocols can assign a label for those IGP learned prefixes. LDP, what else? Segment routing, obviously, and RSVP. Resource reservation protocol. So, but if the prefixes are learned via BGP, you have to get the label via BGP as well. In this case, IPv4 or IPv6 plus label, we call it BGP LU. Maybe you heard BGP label unicast. It was first defined in RFC 3107. That's why we call it RFC 3107. And there are many applications for that one as well. Many other applications than just advertising instead of IGP via BGP. For example, seamless MPLS is a real use case in mobile networks. You see a lot. But also we have carrier supporting carrier. Carrier supporting carrier will be interesting topic. Today, Nicholas shared one document. He did design SIMs and he shared one document on the CSC, carrier supporting carrier, and came to my group also. I seen there and I checked the document, very fast skimmed through, and wanted to talk about that, but required for me to share my screen and little bit advanced, to be honest, what I will talk there. So I need to bring my students, I need to tell them, so it will be beneficial for them as well. So that's why it's very short notice for them. We will do this, maybe live, but might take a couple hours, and Nicholas also will join that. Basically, there are things needs to be explained, because when you read, you may not understand. Who here just read the RFC and understand everything? No one. Maybe I am lucky that most of them, if I am calling them, they are okay to talk also on sessions. Especially, you see those routing space, a lot of videos on the YouTube channel also, and we will increase them. There are many approaches, especially for the BGP security stuff you will watch in the YouTube channel. For example, ASPA with the Alexander Asimov, ASCONS with the Melchior. So many stuff you will watch. Hopefully, now you learn this YouTube channel and you will hang around and you will check the videos, you will get what I am talking, and live session you will not miss as well. So your answer is obviously 50 to 83. You got the point. Why /32? Because earlier than 50 to 83, that RFC, LDP requires for the exact match. You cannot summarize. If LDP will assign a label in the forwarding table, it has to see /32 also. Which brings me to another discussion normally. Who asked that? Mohammed Reza. Which brings us to another good discussion of the segment routing people. Because this, having LDP assigning a label, if he doesn't see the exact match, he will not assign a label, is in architecture, we call it coupling. Okay. So it wouldn't be a problem, for example, with the SR. But with LDP it is. Also, there are many other stuff that, for example, came to my mind when you use LDP, Mohammed Reza. As you might know, IGP LDP synchronization might be another issue, which means in case of failure, and then that failed device or link or node or SRLG, whatever, come back, what will happen to the traffic, right? Because of the convergence time difference between overlay and underlay, you might see black holes. Okay, and this is normal and very known problem, not just with the only IGP LDP, IGP BGP as well, spanning tree HSRP as well. So I call them interaction. RFC call them synchronization. RASFITE call them surface. So I don't know, whichever you choose. Which means this interaction is important to understand in networking, okay? Because networks, we don't have only single control plane, single data plane. So many things interacting, and in overall, not maybe network design, but designers also call it butterfly effect. If I change something in my local area, how it will affect my wide area or data center, or if I change one protocol in my local area, in the same local area, maybe same place in the network, what other things will be affected? Classical example, spanning tree HSRP, for example. Since there is no preemption in the HSRP, when there is a failure, you will see, you might see forwarding loop or suboptimal forwarding. Okay, and is it important, guys? Whatever you learn, when you deal with the design and architecture more and more, you will start changing your design mindset, your architectural mindset. Because you can tell me something, Orhan, is packet loss good thing or bad thing? I will again tell you that it is not good or bad. Depends on the situation. Orhan, even packet, yes. If suboptimal routing, is it good or bad? It is good in some cases, it is bad for other cases. So, you got my point. Suboptimal routing. Obvious example for suboptimal routing, it is good because you do intentional traffic engineering. What does it mean? Okay, let me not go there. Already 1 hour and 5 minutes, but there are other questions probably. Let me try to also go through them. Let's see. Who got the answer last time? Okay, Mohamed Rezaga. I have heard cases where we use /31 non-routable subnet. I don't know how it works. Can you explain? /31 you use, but what's the purpose? Because there is no, maybe they are using public space and they don't want to use the much IP address there. Other than that, classical 126 or 127 IPv6 subnet assignment was the case. I'm not sure about that. If not vesting of IP address, probably I wouldn't go that bad. But some people, if they are using public IP address space, the obvious reason, IP address exhaustion. Okay. Multipoint topology using native IP multicast PIM. What all convergence options we can explore in failure, or we need MPLS to improve the convergence? Of course, I mean, there are many fast convergence methods, guys. In the very first minutes of this video, by the way, I was just talking about fast convergence and fast reroute. And by the way, I think when I finish this broadcast, it will be automatically also watched. So you can watch the video after I close, so you can have a look at the fast reroute discussion there as well. So we have so many methods, but you need to first understand fast reroute is data plane technique, so we need to always tunnel or tunnelless. So traffic engineering MPLS, RSVP, for example, we have tunnel, but on the other side, LFA, for example, we don't have tunnel. So, but always we put those backup paths as a backup into the revamp FIP. Okay, they are not ECMP, they are not UCMP or weighted ECMP, but they are backup, but pre-computed. So there is no loop in terms of convergence. We know that they may not be optimal, so we are not guaranteeing post-optimal convergence path other than TI-LFA. So we are installing those pre-computed loop-free path into the revamp FIP. This is the common across all the FRR mechanisms. Now, when it comes to pure native IP multicast, the question is, do we have, are you asking fast reroute or convergence technique? What you're asking, where was the question? What happened? The question is where? Here. Need to improve the convergence. Of course, I mean, you can improve the convergence by tuning the timer, just if you are asking that. So for the fast convergence, we need to know, of course, the convergence steps of the routing protocols. Usually we have those 4 high-level steps: failure detection, propagation, processing, and FIP update, right? You can tune those timers. All those timers are tunable. OSPF LSA, we have exponential backoff. We have, for the throttling, LSA, SPF throttling timers, pacing timers. We have, you can use BFT for fast failure detection, FIP update. You can prioritize those /32s, and lots of things, okay? For the convergence, you can tune those timers. But also we have fast reroute techniques that we don't have to tune the timers. With the fast reroute technique, we calculate the loop-free path with the many techniques. By the way, Orhan Ergun fast reroute mechanisms, if you read that article, you will find a lot of different fast reroute mechanisms, not just today popular ones like LFA, remote LFA, TLFA, etc. It's there, of course, since decades. We have RSVP-based TFRR, it's there. In that article, we have some academical approaches I covered, like not via, U-turn alternate, what else? Angular distance, what else? MRT, maximal redundant trees, etc. We have so many. When it comes to specifically multicast, for the IP network, you can have FRR, which IP multicast can get the benefit, of course, any of those mechanisms for the IP. They cover the IP control plane, but also specifically for multicast. Let's say, Orhan, we don't want to introduce FRR just for, I mean, we don't want for the unicast, okay? There is also a solution for this called MoFRR, multicast only FRR. You don't need to, I mean, answer lots of things I again gave you as an answer. You don't need to deploy MPLS for taking the advantage of MPLS-based fast reroute. No, MoFRR, for example, just for multicast and totally unique, without any MPLS, you can deploy into your network. Of course, it works based on active-active. Always there is trade-off. You will check, maybe you will come up later on, Orhan, but this one you need to have 2 disjoint paths. So, and you are sending multicast traffic live. There is no free lunch, of course. I mean, you are looking something, and there will be always trade-off. This one trade-off will be a very obvious one, but there will be other trade-offs as well. Very obvious one is the more capacity usage, but you will get fast reroute, which means the fastest, actually, MoFRR will give you fastest multicast conversions. Okay, another one very fast. Trying to learn data center design with VXLAN, EVPN, BGP, VTAP, etc. Configuration need to start from basic. What would you recommend? Would you make some basic videos? Sorry for none. That's okay. For the very basic, what you can do, I think we have many videos on my YouTube channel, but they are not basic, to be honest. And our discussions, especially for those videos, other than maybe EVPN route types, usually the other videos are real-life design on EVPN, etc. So you will see 2-3 videos, I think, for the real-life EVPN in the data center, large-scale data center design videos. You will find Alvaro, we did one, Ramiro, we did another one, and I think there was one guy, I couldn't remember now. 3 videos, they are advanced. What would be, for the EVPN, there is a Dinesh wrote one nice book, okay? Have a look at that one as well. Dinesh Dutt, I think. Free PDF, so get it and start reading that book. Tony Passanen book is very, also configuration intensive, especially. Not very basic, I can say, but good book and very cheap also, $7 or $8, something like that. Have a look at that one as well. And when you increase your knowledge, and join all my live session, and whenever you cannot find the answer, ask here very fast, I can answer for you. And then watch my videos. Whenever you find me, I will try to help you also, guys. What else? Okay, number of questions increased, 1 hour, 10 minutes. What else? People say that SD-WAN may replace MPLS. I am saying that one too, which I don't normally agree to. What do you think? And yes. Now let's understand a couple things, and it will replace. Okay, MPLS is used for transport and service. First time, maybe I will have time. Actually, I can talk too much, but it's already long. Let me try to summarize you by what you will still understand. Just listen very carefully. Guys, let's stop the questions, by the way. There are already so many. And even if I try to just finish, Yash asked the last question. I think if I try to finish all of them, 2 hours already will pass. What I was saying, SD-WAN versus MPLS. Very fast, let's go through this one. We have transport as well as service. When you say MPLS layer 3 VPN, that layer 3 VPN, for that one, what are the protocols, technologies involved, right? Let's just remember those. Multi-protocol BGP is necessary. And why do you use that multi-protocol BGP? For service. BGP is advertising label, right? We call it inner label or BGP label or VPN label. Then we have transport. Let's understand this coupling anymore. All the industry should understand this coupling. Transport and service, different thing. So I don't have to use even MPLS for my transport. I can use just IP, plain IP. I can use just GRE. So layer 3 VPN, MPLS layer 3 VPN can be done with the GRE transport. Okay, but of course there is a reason, like processing, like multi-protocolness, and so on and so forth. It makes the MPLS attractive solution anyway. Okay, but transport can stay there. Now let's understand another thing. This is now when you have this MPLS network, especially as a service provider. Why? To make money. You are selling the service to who? To customer. When they get the service, okay, they were getting as a layer 3 MPLS VPN service, and you give some SLA to them. What is SLA? Service level agreement. So you tell them pop-to-pop latency, data center to data center latency, availability-based SLA or latency-based SLA, or many type of SLA you can give them, because this is your private network, not the public internet. You are giving that, right? So far, so good. Public internet, you cannot give guarantee. Because on internet, it might pass through many ASN, and you control your ASN. You don't control your settlement-free peer ASN. You don't control your upstream ASN, okay? You just control your ASN. You are service provider. Customer is paying to you, and customer is not paying to your peer or your upstream transit ASN. Customer is only paying to you. Because of this also, you don't see quality of service in the global internet. We call it best effort. So, okay, so far so good. Customer is basically getting as a service MPLS service from you. But they might get from you also, come to you, and we want SD-WAN service. Maybe your SD-WAN solution is working also on top of the whatever your transport network is. Is it direct DWDM? It is maybe OTN network, optical transport network. So SDH Sonnet maybe, we don't care. The transport for the DWDM, we call it layer 0, for the others layer 1, right? So we'll stay there. But that MPLS as a transport might also stay there. What service provider is selling to the customer will change. What service provider today is a name, they call their service MPLS service to them, right? It will change. Instead of MPLS, because customer, they want to hear SD-WAN service. Probably you will couple some other good things, goodies, like, okay, we are giving also portal to you, so you can manage some stuff, or maybe just even more advanced monitoring you can get with this solution, SD-WAN, so on and so forth. Name will change, and what customer as a service gets will not be, by the time, will not be MPLS. By the time I put there as a buffer, because we also wanted this V6 too badly, right? 30 years ago, and still we are looking 25, not 30 even % adoption for the IPv6, and we are still saying for some foreseeable future IPv4 will stay there together with the IPv6. And how long SD-WAN will replace, how much time we need for that, I cannot estimate, but it will be faster than, in my opinion, V6 transition. Okay, and you now got the idea. Transport network, we can stay as an MPLS there in the service provider network, but service provider as a what service they sell to the customer, which means overlay, and SD-WAN also overlay. Some people say MPLS is underlay and SD-WAN is overlay. That's why they are not comparable. They are not, if you think in this way. But MPLS is not only transport; it is service. Service provider sells as a service. Okay, and that's why it can replace, correct. And also, by the way, there are many apple to orange networking protocols we still compare. Let's not forget that one. Classical example, DMVPN versus GetVPN. DMVPN is for reachability, GetVPN is for encryption. But most of the time you will compare them, especially in the certification exams. Okay, let's continue now. Oof, a lot of still questions there. What was that? SD-WAN method. In my WAN, I am using IPv4. Okay. Why we need SA4? Already I explained that. Probably you didn't hear that. We talked about that, LSA3. Because I'm paired with other IBGP with my loopback, I need IGP. Is there any other reason to have IBGP and IGP? Is your question IBGP as well as IGP, why it is used? Mohammed Reza? Very fast, let me answer. So if the question is different, so then come, because normally very easy to see. IBGP and IGP is used together because IGP provides those IBGP endpoints reachability. So when you use BGP as IGP, especially in the data centers, BGP as IGP without IGP, you do what? Sessions with those point-to-point interfaces, not loopbacks. So you don't need extra protocol for loopback to loopback reachability. Okay, what else? Segment routing will gradually remove LDP from core. Correct. I also probably agree with them, because it eliminates the LDP IGP synchronization. It comes with the other features like what LDP cannot do. For example, TE, of course, SR, TE, very important characteristics. Traffic engineering. For LDP, you don't have this luxury. We had some drafts we call CR LDP, constraint-based LDP, never implemented. RSVP can do, obviously, traffic engineering, but LDP, no. And you are also saving yourself from those synchronization issues, such as IGP LDP sync, LDP session protections, etc. Those kind of things will not be necessary. Not only those, also you don't need to worry about LDP LSP will be broken if you summarize, etc., so on and so forth. But also, let's not forget the realities that people, instead of migrating from LDP to SR, which is costly, I mean, which is also downtime involved operation, though some people might say the opposite, you don't want to do this without informing the customers. People have priorities. Businesses have priorities. They need to make money. They need to, maybe this might brings extra services to your network, but people might have other priorities already. They don't want to touch working networks also, like football players, right? If someone is playing very well, you don't want to remove that guy from the team. LDP is not that bad. Might bring some benefits, but people have priorities also. What else? What is this? Did we talk about old questions so far? Adil said thanks. Dr. is saying something. I think he's not asking question. In WAN, I am using IBGP. Okay, we talked about that. What would be the advantages of? We talked about that one as well. Thanks. Okay. What else? Many thanks. VXLAN is L2 or L3, as it is also L3 extension. Got asked in the interview. Guys, if you have question, please ask. If there's comments, let me not talk if you already know what you are asking. Is OTV the best DCI technology for LAN extension? Of course not. First, I wouldn't say anything, even for the EVPN best, but probably if there is any best, it would be EVPN, not OTV. And OTV works good. ARP suppression is there. OTV provides layer 2 extension. It is using ISAS there. At the end, there is no active solution for that one anyway, as you might know, because maximum you can have VLAN-based load balancing, odd-even VLAN separation. It works based on odd-even VLAN separation. So one link is responsible for VLAN 1, 3, 5, 7, 9, etc. Another link is just even VLANs, such as 2, 4, 6, 8, 10. But EVPN on the other side is, I mean, active-active multi-homing is one of the most important capabilities. We can count those LDP EVPN, in the EVPN case, MAC withdrawal, etc. These are very helpful for the convergence. I mean, OTV lacks lots of features which EVPN could do, of course. Still, is it good solution? Yes. I didn't even talk about the being proprietary, by the way. Usually I don't care, but some people care as well. And not only that, when EVPN gets very familiar by everyone, already deployed by merchant silicon, I mean, a little bit maybe complex, but people will understand it by the time. OSPF much complex compared to ISAS, but people more familiar with OSPF. Depends on documentation, depends on number of deployments. There is no best, but from many aspects, I think EVPN would be that DCI solution what I would prefer. I wouldn't push my company to invest proprietary solution while EVPN is there. What else? Orhan, can I get your free course for answering Yash question? I answered already. And many people can answer many other people question, but obviously the people here to hear my answers, right? For the OTV also, we talked about that, and I think it was the last question. Almost 1.5 hours, guys. So if you are not subscribed to this YouTube channel, please do that. And if you like this video, I would be happy, because then many other people can see this video as well. And if they had these questions also, they can get the answer. And if you are a subscriber, next time when I open the live session, you can get the notification. You got the notification, I think, now. That's why you are here. So you can prepare your question, maybe not write somewhere, but at least you can remember, and then we can discuss next time when you come. And we do the discussions. Not each and every time I can have maybe 1.5 hours, but because maybe you heard my daughter got the coronavirus and we have to stay at home, and 15 days almost. So I have so much time these days. I can open these sessions, you can join, we can discuss. Otherwise, of course, you might know that orhanergun.net is my website, Orhan Ergun LinkedIn, and Orhan Ergun CCD is my Twitter handle as well. Please, let's connect there. I have so many courses. Usually, I teach CCDE and CCIE, Enterprise and Service Provider, those Cisco certifications, but sometimes also technological, just technology classes we are doing, especially BGP Zero Hero, the probably famous one you heard maybe, 5 days, 25 hours, just design course. We don't configure anything there, but we have also self-paced version of my courses. Okay, self-paced version mean while I am talking, we are recording them, and plus in the self-paced course we are adding configuration videos as well. I don't configure, other instructors are configuring those features, capabilities. Then you can watch them. Any other thing? Thank you for that. Thanks a lot for the good wishes, guys. She's totally fine. We are fine as well. Her mother, her brother, we are fine. Just we need to stay at home, so we shouldn't affect other people. But still, thanks for the good wishes. And probably in a couple days, maybe even tomorrow, I can open this live stream and we can continue the discussions. And bye for now.